Okay, so in the last lecture, actually, we have started unit number 3, that is knowledge representation and reasoning. So like human has a knowledge representation as well as reasoning. Likewise, if machine starts having knowledge representation and reasoning, then it becomes an intelligent machine. So we have seen some part of it, like we have seen last time how well this knowledge representation and reasoning plays an important role as far as AI is concerned. So one of the key player as far as the artificial intelligence in software, machines, technology, as well as knowledge. And when collaborating with humans with the help of to accomplish some kind of task which was unimaginable before, or it was very limited to fiction, because of knowledge representation and reasoning, it became easier. So we have started seeing this. In the last lecture we saw this one. So beyond this, one more important part is that when we start defining artificial intelligence in terms of knowledge representation and reasoning, it means that the AI is actually the study of intelligent behavior that is achieved through the computational means. This is very important as far as artificial intelligence is concerned. Now, computational means in case of AI is equal to thinking of an human, right? So if you want to compare with an human intelligence and artificial intelligence, then the intelligent behavior achieved through computational mean is nothing but the thinking of an human behavior. Like, so in humans we have thinking, whereas in case of intelligence, artificial intelligence, we have computational means. Knowledge representation and reasoning is an part of an AI that is concerned about how an agent uses what it knows in deciding what to do. So similarly, like in humans, if you gain some kind of knowledge, then your intelligence mostly can be defined or can be defined as like how you're using that knowledge in a particular application. So similar in case of artificial intelligence, the same thing happens. So that is possible with the help of knowledge representation and reasoning. So we could also say that it is the study of thinking as a computational process. So how this knowledge representation and reasoning can be represented? So it can be represented with the help of symbolic structures. Then we saw that how this knowledge representation and reasoning is needed in order to create the intelligent machine, which is nothing but a very important part of artificial intelligence. If you look at the block diagram, you'll come to know that almost all AI systems consist of following components. So this is a very common block diagram which is available in all AI systems, and it is also called as an AI knowledge cycle. So you have a perception. In case of perceptions, you have two outputs. One is a learning and the other one is a knowledge representation. Then knowledge representation is going to reasoning, and this reasoning is going to plan, and then it is going to the execution. So planning and execution is the last block, learning is the second block, and the knowledge and reasoning is the third block. So this perception is actually taking the inputs from the environments, then it is giving to learning for the learning purpose, as well as that knowledge with the help of learning can be easily represented with the help of knowledge representation. Then by reasoning, these two blocks will take the information from the learning, or it will take two informations directly, that the information which is gathered from the environment, or the information which is learned by the learning process. So at that time, knowledge representations with the help of reasoning will process the entire process, which will be given to the next step called as planning and then execution. So if you look at this one, you will come to know that what perception is. It is nothing but getting the information from its environment, or I could say that the types of various inputs from the sensory information. Then learning is what? It is a component that is an adaptive and helps to perceive data, that is used for perceiving the data or drawing some kind or learning something from the data. And then comes the knowledge representation. So knowledge representation actually is nothing but after collecting the information, it will give a meaningful representation. So that could be either statically, which it has got from the perception, or it may be in a combination with the learning components. So though in both the ways it can work out. So this knowledge representation and learning is given to the next cycle, which is nothing but planning and execution. So the two phases, that is planning and execution, are dependent on the analysis of knowledge representation and reasoning. So obviously in the whole entire process, if you look at, you'll be finding that knowledge representation and reasoning is very important part, because it is the block between the environment gathered and the execution of the knowledge gain. Planning and execution. So it is the in between block between the information that is collected from the environment, which is learned, and the planning and execution. So in this way, the AI knowledge cycle can be represented. So this is the whole thing of what we have explained. Now, if you look at differently how you deal with this knowledge and representation and what actually it means, we started with this. So actually knowledge is nothing but it means that the world, taking the world to be one way, not the other way. This is how the knowledge is always defined. So you're going to take the information in one way. At that time, you cannot take it in the another way. So when this happens, it is called as knowledge. Second is a representation. So a representation actually is nothing but the relationship between two domains. First means stand for and take place of the second. So usually first domain, the representer is more concrete, immediate, or accessible in some of them, the second one. So the first domain and second domain, both are very important as far as representation is concerned. The type of representer that will be concerned here is the formal symbol. Now let us assume that there is a digit 7. So example, it will be standing as a number 7 also, or it may be group of letters 7 also. So how you represent is very, very important. As with all representations, it is assumed to be easier to deal with symbols. If you compare with these things, it is most easiest way to go with a symbol representation. That will help you to recognize, distinguish from each other, display them as compared to the other things. So that means symbol representation is the most easiest representation of all. Now, what are the benefits of this representation? As we know that if you want to add new task, it can be easily added because you're adding symbols. You can extend the existing behavior of adding new beliefs. You can debug the faulty behavior by locating the erroneous beliefs. So obviously everything now here, the error is nothing but adding or removing the beliefs. So you can also extend the behavior by adding some kind of belief, and you can also remove the belief if you find that it is not good enough. That is debugging, because we are into the world of AI, so which is something different. So in this erroneous is nothing but it is related with the beliefs. So explain and justify the behavior of the system. So representation always helps you in that case. And representation means symbol standing for the things in the world. So it does mean that how the symbols structure are representing the data is nothing but representation. So you can just see that if you see that the plus symbol, as soon as you see the plus symbol, it immediately you can see that it is about a first ad, right? Now this symbol is representation of women's. Then if you see writing a text John with an colon with the apostrophes, at that time we say that it is the name John. John loves Mary. That means again it is a proposition that John loves Mary. So in this way, symbolically how you represent, is very, very important. And henceforth, the knowledge representation or the data representation plays a very, very important role. Now, if you go with knowledge and you came to know representation, now with together, we are saying it as a KR, called as a knowledge representation. So now what is knowledge representation? It is the symbolic encoding by some agent of propositions believed. So obviously you're encoding something with the help of agent, and the symbolic structures are the most important of what? The propositions that are believed. So it is actually a symbolic encoding by some of agent of propositions believed. It is the area of AI that deals with the problems of representation, maintaining, and manipulating knowledge about an application domain. So what is KR together? So obviously it is the area of AI that deals with the problems of representation, maintenance, and the manipulation of the knowledge about any specific domain. Since virtually all AI systems have to address this problem, KR is one of the central subfield of AI. So जहां जहां पर representations की जरूरत पड़ती है, जहां जहां representations important होता है, क्योंकि ये सारा problems हर AI systems में होने वाला है, उस जगह पर आपका care एक बहुत important role play करता है, because it is one of the central subfield of AI. Now, what is the main concept that is related with this KR? What is the main research behind this KR? So the first is representing knowledge about application area. That may be medical knowledge, knowledge about the time, knowledge and about the physical systems. Now see, when you want to represent the knowledge, then the question arises in what form this knowledge is. Obviously, the representation of the knowledge about any application, if we consider, then the knowledge that is related with that application means it could be a medical knowledge, a time knowledge, a physical knowledge, or anything else. So obviously for representing knowledge, you need to have a very important thing about is the knowledge about the application. Developing appropriate representation language. Just to represent this knowledge, you need to have a language that is easily representative. Specifying and analyzing reasoning over represented knowledge. Obviously, just to specify is not a very important, specify just is not going to be enough. You have to analyze the reasoning over represented knowledge. What is the reason for this thing? So that reasoning has to be given. Implementing systems that support the representation of knowledge and reasoning over represented knowledge. So obviously, first is representation of knowledge and then giving reasoning of that represented knowledge. So there are two things which is very important. As soon as we go with the knowledge representation, then you are representing the knowledge. And second is you should also know the reasoning about the represented knowledge. Now, if you look at the knowledge representation, there are some of the points that has to be considered while we understand knowledge representation. So if you see that one example, if you taken like a program code or implicitly as a pattern of activation in neural network, you can take any program code, or it may be you may consider the patterns in the neural network. Research in the area of knowledge representations assumes an explicit and declarative representations. So if you look at the application domain where your knowledge representation is there, so in which form, sometimes it may be in the program code form, sometimes maybe it may be in a pattern form. At that time, the most important area of the knowledge representations that it assumes an explicit and declarative representations. An assumption that distinguishes care from the research in like programming languages and neural networks. So obviously, if you go for a program specific, then there are different ways of knowledge representation. And one of them is a program code and the other one is the pattern that may be coming into the neural network. Explicitness of representation means that represented knowledge is stored in the knowledge base. Yes. So the word that comes out here is explicitive and declarative. So I should know that what is this explicitiveness and declarativeness. So explicitiveness means what? You're representing the knowledge and you're storing that in knowledge in case of knowledge base that consists of set of formal entities that describe the knowledge in a direct or unambiguous way. That means what happens is that there are two important things in this. First is, if you go with the knowledge about the application domain, then the the form of the knowledge will be in the form of program code, or it may be the pattern activation in the neural network, right? Then the area of knowledge representations actually assumes the explicit and declarative representation. Out of this, if we say what is explicitness, then it is nothing but representation of the knowledge, and the knowledge is stored in the knowledge base. When it is stored in the knowledge base, it consists of formal entities that describes the knowledge in a direct or unambiguous way. So that is the representation and defining of the knowledge. That is very important. Then second is part is explicit and then declarative. So now what is declarativeness? Explicit, we know, storing the knowledge in the knowledge base. Now what is declarative? Declarativeness means that formal meaning of representation can be specified without reference to how the knowledge is applied procedurally, implying some sort of logical methodology behind it. Yes, declarativeness means what? When you're representing a specific kind of a knowledge, then what kind of logical methodologies behind that knowledge? Suppose if I'm knowing something and I'm applying in some of the applications, then is there any kind of logic that has been there in order to apply for that particular application? So that logical methodology has to be very, very important. So this is called as the explicitiveness and the declarativeness. So these two words are explained here. Okay, so once again, if we go with the revision, then what is knowledge representation? It is nothing but knowledge of the representation can be represented in varieties of forms. Some of them like program codes, or it may be the patterns in a neural network. Then the area of knowledge representation assumes explicit and declarative representation. What is explicitness? It is nothing but representing the knowledge that is stored in the knowledge base. And what is declarativeness? It is nothing but implying some sort of logical methodology behind it. So this slide tells about all these things. We are into knowledge representation. We have seen what is knowledge. We have seen what is representation. And now we are seeing knowledge representation, that is called as KR. So two most important things: explicitiveness and declarativeness. Now, after understanding knowledge, then representation, and then knowledge representation, the fourth parameter that is important is nothing but reasoning. Now, I always say that what is the difference between artificial intelligence and human intelligence? So obviously, if we go with human intelligence, knowledge representation is important, but the reasoning, what it makes it to be an intelligent. So when you add this reasoning in case of artificial intelligence, then we say that the machine has become intelligence. So when I am having a knowledge representation as well as reasoning, then I could say that humans are intelligence. So in that way, reasoning plays a very important role. So it is a formal manipulation of symbols representing a collection of believed propositions to produce representation of new ones. So कुछ डेटा का इस्तेमाल करके new representation करना, like representing some collection of the believed propositions कि भाई ये काम ऐसा करता है, वो वैसा करता है, ये जो propositions believed है उन्हीं का इस्तेमाल करके नए representations form करने का काम reasoning करता है. करेक्ट है? Because reasoning is what, like I'm having some kind of information at the back of my mind, and then I start implementing it where I feel it is to be needed. So how you're going to apply it? It is through the reasoning. And this way we can say reasoning. It is here that we use the fact that symbols are more accessible than the propositions they represent. As I said, that symbols are very easy to represent. They must be concrete enough that we can manipulate them. That is, move them around, take them apart, copy them, string them together. in such a way as to construct representation of a new propositions. So आप जो symbol structures इस्तेमाल करेंगे representations के लिए, they should be very concrete enough. Like concrete enough means what? You can play with them, you can move them, you can separate them, you can copy them, you can string them together. So if that is possible, then only it is possible to produce a representation of the new ones. Then only it is possible to construct a representation of a new propositions. So if I know, sorry, if I know that the collection of believed propositions and I want to go for a representation of a new one, then I should have some kind of information with myself. So what kind of thing that is needed here? We are needing here the concreteness. They should be very concrete. So we can easily move them here and there, copy them, paste them, separate them, attach them, bring it together, so that it is possible to construct the new representations or representations of a new propositions. This is very, very important. Okay. So this is very, very important. So the believed propositions can be helpful you to produce representation of new ones or representation of new propositions. That is what I mean actually. Reasoning is a form of a calculations and not unlike arithmetic, but over symbols standing for propositions rather than numbers. This is a very important line. It is actually calculation, but it is not like an arithmetic. It is about the symbols that is meant standing for that proposition rather than numbers. So obviously, like arithmetic, you go for numbers. Reasoning is a calculation, but it is not about the numbers. It is about what? It is about the symbols that is meant standing for the propositions rather than numbers. Reasoning is a manipulation of symbols encoding propositions to produce representations of new proposition. The same thing. So you're going to use the collection of believed propositions to construct representations of new propositions. That is what actually reasoning means. Now, what are the benefits of reasonings? So you can see here, there are two analogies present here. One is the arithmetic, which goes with the calculation of numbers, and this goes the calculation of symbols. So there are two differences. Like arithmetic reasoning, if we see that you are using some kind of digital numbers, and those numbers you can go for different combinations and go for the calculations. But when it comes to the reasoning, as far as in artificial intelligence is concerned, at that times we are going to use the symbols, right, to represent that knowledge. Like example, if you see here, so 1011 plus 10, so 1011 is 11 plus 1, I am adding 2 into that, so 11 plus 2 is becoming 13. This is a simple arithmetic calculation. Now, but when I say that there is a symbol called as John is Mary's father, and there is the another one where I say that John is Mary's father and John is an adult male, that means there is a reasoning behind it that John is an adult male. When he's a father, that means he's an adult male. So that kind of reasoning is implemented as far as AI is concerned. That's a symbolical reasoning. That is symbolical representation, which is nothing but using the believed propositions to go for a new representation of a new propositions, propositions of a new propositions, representation of a new propositions. So in this way, you can use the symbolical structure calculations for doing the reasoning. Now, what are the benefits of reasoning? The benefits is that when I take an example like patient X is an allergic to medicine M. So any one allergic to medication M is also allergic to medication M, obviously. अगर मैं ऐसा बोलूं कि पेशेंट एक्स है जो कि एलर्जिक है मेडिसिन एम के लिए, इसका मतलब जो भी मेडिकेशन है एलर्जिक के लिए, इसका मतलब एनीवन कैन बी ए पेशेंट हु इज एन एलर्जिक टू टेक इन मेडिसिन। सो अगर पेशेंट एक्स है जो कि मेडिसिन को एलर्जिक है, तो इसका मतलब एनीवन हु इज एलर्जिक मींस is an allergic to medication M. Same thing. This is nothing but the reasoning. This is the best example of reasoning. Reasoning helps us to derive. Like example, patient X is allergic to medication M. That is derivation. What is the conclusion of all these things? That means patient X is an allergic to medication M. So you're going to derive something with the help of reasoning. So these are some of the benefits of reasoning. Now knowledge representation and reasoning in AI, now all combinations. Now first we saw what is knowledge, then we saw what is representation, right? Then we saw knowledge representation, which is nothing but KR. Now we are saying KRR. It is actually also known as KRR. Sometimes in the question paper, you may get like, what is KRR or explain about KRR. Then we should be able to know. And that's why I've changed here KRR. In some of the books, it is given as a KRR, that is knowledge, representation, and reasoning. Now, all three will go together. And when these three things will go together in AI, the entire process becomes very smooth. So how this knowledge, representation, and reasoning together in AI works out, that's we are going to see. Humans are well adapted to the ability to perform assessments and use reasoning to make decisions suitable for the situations. Same thing, what I said is that humans has the ability to adapt, to make an assessment and use the reasoning to make a perfect decision or suitable decision, which is very much suitable to the situation. So based on the situation, you are going to take a decision. So actually reasoning helps us to make or to take a very perfect decisions based on the situation. So humans can do that. Like for example, in a situation where I'm being thrown in front of dogs, this is the situation. Now what my knowledge, representation, and reasoning says that what kind of decision I should take that is suitable for that situation. So that is nothing but knowledge, representation, and reasoning. However, machines and computer systems are dependent on varieties of technologies to fulfill this task. Obviously, humans are very multi-dimensional type of animals. They have variety, uh, they have the knack to do a lot of things at a time. But if machines and computer systems is to be done, then they are very much dependent on varieties of technologies. They have to go with a lot of technologies. They cannot just rely on one technology. So what kind of technologies these machines have to adapt to fulfill these tasks, such as natural language processing, because when we speak, we learn how to speak. Similarly, machine also require that kind of natural language processing. Machine learning should be able to learn by itself. Deep learning, then speech recognition, the virtual agents, and much more. So in order to perform like humans, the machines and computer systems has to rely on different technologies. And these technologies are must to them in order to take any kind of decisions. So we have seen some of them like NLP, ML, DL, speech recognition, and the agents that may be virtual agents or in the intelligent agents. These agents is one of the technology that computers or machines can adopt. Among these, knowledge, representation, and reasonings are central to the field of AI. as they consist of things that makes machine capable of performing tasks like human. But as compared to what we have seen about the now technologies, when you go with these technologies, and if you compare with the technology that is provided by the knowledge representation and reasoning, you'll come to know that it is by far the very, very important as far as the other technology is concerned, because they make machine capable of performing tasks like human. In the field of AI, knowledge representation and reasoning, that is KR2 or KRR, represent the information about the world in the form that can be utilized by the system to solve complex tasks. So KRR in artificial intelligence can be used or can be utilized by a system to solve complex tasks. What complex tasks? We are going towards in such an area where a lot of things are happening in medical also. This AI will be playing a very important role in medical diagnosis, problem solving, knowledge reasoning, and much more. So beyond those technologies that are required by the machines and computer systems to take a perfect decisions, in that, if you could see that knowledge representation and reasoning plays an important role as far as solving the complex task is concerned. So they are just more than enough. Moreover, knowledge representation and reasoning work hand in hand with automated reasoning to assert new information and knowledge, make inferences, which is a part of all knowledge representation languages. Obviously, you cannot go with separate knowledge, separate representation, separate reasoning. These three have to go hand in hand. Then only you can assert new information and knowledge. You can make inferences, which is nothing but part of all knowledge representing languages. So they are going to go hand in hand, and then only it is possible. Now, how this knowledge representation in AI plays an important role? Because we have seen what knowledge representation is, like representing a knowledge and then reasoning of that represented knowledge. We have seen two parts. That is, one is the knowledge, the other one is representation, third one is representation of that knowledge, and the fourth one is what we have seen is reasoning of the represented knowledge. That's the basic idea of what we have seen about knowledge representation. Now we're little bit going into deep. We are going into AI now. We are going into deep. So initially I have given you the information what they are. Now we are actually going to implement them, like where it can be used. So the first part what comes into the picture is knowledge representation. We'll take that only knowledge representation. So it is a sub area of AI, mostly concerned with understanding, designing, and implementing ways to represent information in computers. So same thing, repeatedly I've been saying, it's a representation of a knowledge. Obviously it is some kind of part of an artificial intelligence. So it is mostly concerned with understanding, knowledge, designing, implementing, or representing the information in computers so that it can be utilized by agents to perform varieties of tasks. Once you have a knowledge representation, then the agents can utilize them to perform various tasks, like converse with the people in natural languages, determine the course of action, plan future activities, perform human-like problem solving. So in order to perform like what artificial intelligence can perform varieties of tasks, you need to first of all know how to represent the knowledge. Because we are being concerned with understanding, design, and implementing different ways to represent knowledge or information in computers. So that will be helpful in order to perform various tasks. Now, what are the approaches to this knowledge representation? So there are different approaches of this knowledge representation. The first one is a simple rational knowledge. So what kind of approaches are there for knowledge representation? One of them is simple rational knowledge. It is the simplest way of storing facts which uses rational method, and each fact about set of object is set out systematically in columns. So it's a very simple way. If you see that, it's a simple relational knowledge, means storing facts. Simplest way of storing facts. This approach of knowledge representation is famous in database systems, like relationship between different entities is represented. So best example ये है कि simple relational knowledge is nothing but storing the facts, and the most important way to apply it is in applying database systems, where you can find out the relationship between different entities. This approach has little opportunity for inference, so you cannot infer there. This is what the limitation of simple relational knowledge is about. Then we go with inheritable knowledge. In inheritable knowledge approach, all data must be stored in the hierarchy of classes. So there are hierarchies. Like if you give the example of engineering college, you have an head of department up there. Like first you have a principal up there. Then you have deans. Then you have HODs. And then you have faculty members. So there are hierarchies. So in this inheritable knowledge, all the data must be stored in that particular hierarchy of classes. So this is class 1, class 2, class. So there are hierarchies that is being followed. All classes should be arranged in generalized form or the hierarchical form, obviously. Same example. In this approach, we apply inheritance property, right? Elements inherent value from other members of the class. This approach contains inheritable knowledge, which shows a relationship between instances and class, and it is called as instance relationships. Each and every class in that hierarchy is having some kind of relationship with each other. So what does it mean? That the principal is having a connection with the deans and head of departments, and directly that means the principal, if you want to give the message to the faculty member, it has been transferred through these two. So there is a hierarchy of going through it. So everyone is having an instant relationship with each other, and that is nothing but inheritable knowledge. Every individual frame can represent collection of attributes and its values. In this approach, objects and values are represented in box nodes. So obviously, when there is an hierarchy, I said that at the top you have a principal, then you have deans, then you have HODs, then you have different faculty members. So when you represent in it in a block diagram, then you have different blocks you can represent. But again, knowledge representation through the symbolic representation is going to be important. Likewise, you are representing this type of knowledge representation through the box nodes. So this is an inheritable knowledge. So we use arrows which points from objects to their values. So you can have this. One side there is a Peter, and then when there is an Ankit. So at this instance, Peter likes to play cricket. He's a cricketer, and Aniket at this instance would like to play football. So he's a cricketer, he's a football, but both are players. And both are players and both are adult male. Both are male. So there is an hierarchy going through how it goes like. So through these box nodes, you can approach this kind of representation. This is an example. The third one is an inferential knowledge. Inferential knowledge approach represents knowledge in the form of formal logics. So logically, A is a father of B. That means B is the son of A. It's a logic. So the knowledge representation through an inferential knowledge will be in the approach will be through the form of formal logics. This approach can be used to derive more facts. So I said, if it is given one, it will go to derive more facts. It guaranteed correctness. Example you can take. Let's suppose take two statements. Marcus is a man, all men are mortal. So when we represent it in the case of AI, that means man is Marcus, all men are mortal. Hence we can say that the man is immortal. Is it right? See, this man is a Marcus. This is the first thing. All men are mortal. So this is man X, and that is mortal. So you can have the inferential logics that could be in this inferential knowledge, and that can be help you to write down the statements. So below you have two statements you have seen, and how it is represented you have seen. Fourth one is a procedural knowledge. So procedural knowledge approach use small programs and codes which describes how to do specific things and how to proceed. So you have very small programs and codes that are written together to do a specific thing and how to proceed. One of the most important rule is that if then else. Obviously, agar aisa ho to waisa, if this, if then this. So if then rule ke hisab se you can describe a very specific things, how to do that specific things, how to proceed. In this knowledge, we can use various coding languages such as LISP, which is the second oldest programming language after Fortran, designed for easy manipulation of data string, and the Prolog language. So procedure knowledge, you can write down the coding language. You can write down the coding in various languages like Fortran or LISP or the Prolog. We can easily represent heuristic or domain specific knowledge using this approach. So very domain specific knowledge you can represent, heuristic you can present. So you have seen what is heuristic and what is domain specific knowledge. But it is not necessary that we can represent all cases in this approach. So it again have the limitations. You cannot implement all of them together in this, or different types of things can be represented in this approach. It is not possible. Okay, next is knowledge reasoning. We'll take it next in next lecture. So we'll go with attendance. Today is what? 8/4. So 15, 4:15. A division roll number 1.
Present, sir.
2.
Present, sir.
3. 4.
Yes, sir.
5.
Yes, sir.
6.
Yes, sir.
7.
Present, sir.
8. 9.
Present, sir.
10. 11. 12.
Present, sir.
13. 14.
Present, sir.
15. 16. 17.
Yes, sir.
18. 19. 20. 21. 22. 23. 24. 25.
Present, sir.
26.
Present, sir.
27. 28.
Present, sir.
29, 30,
Yes, sir.
31,
Yes, sir.
32,
Yes, sir.
33, 34, 35, 36,
Present.
37,
Present.
38, 39, 40, 41, 42, 43,
Yes, sir. 40.
40 is there. 41, 42, 43, 44, 45,
Present, sir.
46,
Yes, sir.
47, 48, 49, 50, 51, 52, 53, 54,
44.
44 is there. 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63.
Yes, sir.
Okay, 63 is there. 64,
Yes, sir. Present.
65, 66, 60,
Yes, sir.
okay, 67,
Present, sir.
68, 69,
Present, sir.
70, 71, 72.
Yes, sir. 72.
Okay. Any number remaining in this A division?
Sir, 27.
27 है,
A4.
4 पना है,
69.
69 पना है,
Sir, 66.
66 पना है. B, roll number 1, 2,
Present, sir.
3,
Present, sir.
4,
Yes, sir.
5,
Present.
6,
Present, sir.
7, 8, 9,
Present.
10,
Present.
11,
Present.
12, 13,
Present, sir.
14, 15,
Present.
16,
Present, sir.
17, 18,
Present.
19,
Present.
20,
Present.
21, 22, 23,
Present.
24, 25,
Present.
26,
Present.
27,
Present.
28,
Present, sir.
29, 30,
Present.
31, 32, okay, 32,
Present.
33, 34, 35,
Present.
36,
Present, sir.
37,
Present, sir.
38, 39, 40,
Present, sir.
40, 41, 42, 43, 44,
Present.
45, 46,
Present, sir.
47,